How you doing? And Marc, Kornbluh, representing the company. So take it away.
All right. So, how you doing? Can everybody? I was gonna maybe avoid the mic if people can hear me. So if you guys can't hear me, there are a few more seats down here. You can come this way. But anyway, we're going to talk generally about pressure swing adsorption. Does anybody know that term, pressure swing absorption? Okay. So pressure swing adsorption is basically the process of using this material called zeolite under pressure. Zeolite has little pores. Is it a silica zeolite maybe? Yeah, and they have little pores measured in angstrom, you know, and different molecules will get trapped in those pores at different pressures. And it just so happens conveniently that nitrogen gets trapped in the zeolite at 30 psi. So each one of these little modules that you see in that bank, when it has a compressor and it's got, Carol Merrill will, it's got these, you have to be a certain age to know that one, I think. So anyway, the zeolite sieve beds, they're called, or sieve towers, alternate. There are two of them. And then at a certain pressure, the nitrogen gets trapped and a wave of oxygen, actually it's one at a time, so imagine two cylinders, a wave of oxygen comes down, and then if too much atmosphere goes through, the zeolite gets oversaturated, and at that point atmosphere comes out. So it's perfectly timed so that that wave is oxygen and then it stops, and then the next wave is oxygen and it stops. And in that way, these little machines can produce quite a bit of oxygen. Really, when I tell people how much each one of these little modules make, it's typically very surprising. But any guesses out there? Like in a 10-hour period, what do you think one of those little modules will turn out? 1 K tank.
Very close.
But good.
So does everybody understand what he was saying? There's two sieve beds, and basically they operate like breathing. Mm-hmm. One breathes in, it gets saturated, the oxygen comes, and then it flushes out the nitrogen, and then does it on the other side, back and forth.
Continually.
Yeah.
Yeah, and that's
Is there
so.
an absorbent in any of these?
Pardon me?
An absorbent, like what does it expel?
It expels nitrogen and moisture, so they can work in fairly humid environments because as long as you keep them running. We have them running all over the world in Florida and Hawaii and a lot of very humid places. And as long as they keep running, they'll always work. The problem with the zeolite is if you put them into storage and then you take them out years later, the zeolite gets caked up if moisture gets into it. And then you'll turn them on and they'll blow. You'll have white dust all over your shop. But anyway, they're very effective. The traditional machines, maybe some of you have seen like an AirSep or an OGSI. A lot of universities and hospitals. You've seen the.
Yeah, I've got an AirSep.
You got an AirSep, so with the big sieve towers.
It doesn't work anymore, yeah, but yeah.
You hear that a lot. It doesn't work anymore. And typically, the reason it doesn't work anymore is probably because the zeolite got contaminated.
Right.
That's what almost always happens. So they want to sell a lot of these, and they don't always tell people don't ever use anything but dry air in them.
Right.
Because they can't really expel the humidity. They're not built to expel the humidity. So what you do is you buy one of the units that's got the two towers, and then you have to have a fairly large compressor to feed it, you know, maybe 27 CFM. Because really you gotta push a lot of atmosphere through in order to get that little bit of oxygen. It's only 20% approximately of atmosphere, and so anyway, you need a compressor, you need an air dryer, or one that does both, and you need the sieve beds, and then you need a post compressor to bring it up to whatever pressure you need, because it's only going to come out of the sieve beds at about 30 psi approximately. So anyway, this system just sort of is the shortcut, you know. So, but anyway, that's the more traditional systems. let's see.
Oh, we could mention measuring oxygen purity. So a lot of people, a lot of bead makers traditionally have been able to run off of oxygen concentrators because they don't need a lot of pressure and they don't need a large volume of oxygen. So if they're working with a lynx, likely they're going to be able to use an oxygen concentrator by itself or daisy chain those together. But the larger your torches get or the larger your demand gets, the less that daisy chaining works because you really need more pressure versus volume. You can, daisy chain a whole bunch of concentrators together and you'll add to that volume, but you're never going to add to that pressure. That pressure is going to remain the same. So if you're buying old refurbished oxygen concentrators or used oxygen concentrators, sometimes the purity isn't as high as new medical concentrators. So the new medical concentrators, when they come out, they're meant to have a service life of 20,000 hours. So after they get to that 20,000 hours, then they're shunted into the refurb market where they recondition the zeolite, repour, and do all that fun stuff, and then sell them again to the hobby market. We've got an oxygen purity tester that we use a lot of times. A lot of times if people are having problems with any sort of oxygen system that they're using, it's generally because the purity has gone down on the oxygen concentrators.
Maybe the zeolite has been contaminated.
Yeah, exactly. So we actually have a little oxygen purity sensor that we've got a little ball valve hooked up so we can test our oxygen concentrators if we're buying used ones or getting refurbed, or it's good for diagnosing the tools. But you can actually measure your oxygen purity that way. And typically you're going to get about 92% plus or minus 4% from oxygen concentrators. We had a whole bunch of refurb and used units in our home shop in Lincoln, and I think we were measuring the oxygen purity at 88%, so we changed out some for new and it spiked up to like 93%. None of the glass blowers had any idea what it was, and it didn't make a difference to them anyway. So a lot of people get hung up on the purity, and it's not really essential.
Well, the balance, so if you've got 94% pure, what do you think the remainder is? Does anyone know? Like, what would be left? No, actually, that's a good one, but that's not what it is. It's argon. Argon, yeah.
So it's a nerd
The
actor.
argon molecule is about the same. It's very close in size to the oxygen molecule, so it passes through. It's very hard to scrub the argon. There'll be some zeolites coming out in the future, not too distant future, that will actually scrub out the argon, and then we'll be getting up to 99.5. And what's being used is a silver nitrate zeolite. So there's some new zeolites being developed. And we're involved a little bit in developing those. We've done some R&D in developing, working with companies that develop these. Because it's, once these machines can produce 99.5, then there are other markets like laser that we can get into. So.
Did you have a question?
Yeah, so you said it's like 94%. What is a K-tank that you would normally get it? What would be the purity on that?
K-tanks are pretty consistently, medical oxygen and industrial oxygen are supposed to be different, but they're really not. They do something called a sniff test, and I'll get to your question. I'm just going to go a little roundabout way. They do a sniff test, and that's how they know whether they can fill it with medical or they actually smell. If it's clean, they'll fill it for medical, but it's exactly the same oxygen, and it's 99.5. You can pay a lot more money for 99.7, and the markets that would do that would be doing, very, like some of these. I don't know if you've ever seen these room-sized Trump laser cutters. They have laser cutters now that can really quickly cut 2-inch steel. I mean, you watch this thing, and it's going like that, room size, cutting 2-inch steel for CAT and some of these big companies. And they'll get a better cut and a faster cut with 97 than they get with 95. I mean, it's amazing what a little difference can make. Yeah, it really is incredible. So we were going to talk a bit about, we're in 200 plus locations around the world. We sell a lot of systems overseas. Japan's a big market, in Europe. There are a lot of places where a tank of oxygen, like a K tank of oxygen, costs 100, 150, 700 for a liquid.
Yeah, I went to Hawaii a couple of years ago. There was a glass blower there, and he had a system like this, and he said because the tank of oxygen was 150 done.
Yeah, yeah.
So,
Yeah, New
it was a
Zealand.
no-brainer.
Same in Australia. We've opened up that market a little bit, and yeah, it's sort of before we developed this system. Generating systems like the one I described were, I want to say, 40 grand for a system that wasn't quite as powerful as this. And a system like this sells for about 18. So, and this is for a personal shop, really about 10, for one or two torches. So I think what's happened is with this idea, people can get into generating systems that couldn't before. So it's become an option. And yeah, so we're kind of making, I feel like our happiest, the happiest people we know are the ones in places where they're like, I would not be blowing glass without this.
Remote
It just
locations,
would be
Australia,
impossible.
Alaska is really expensive
Alaska's
as
big,
well.
yeah.
Yeah.
So we go through a process with people when we spec a system where we want to find out exactly what they use and how they use it, because a lot depends on the flow rate. The pressure is kind of a no-brainer. We go up to 150 psi, but a lot depends on the flow rate that they need. And really, in order to figure that out, Carrie's gotten really good at asking all the right questions. So
Yeah.
we thought we'd talk about that for a little bit.
Yeah, so generally if somebody calls me and they're interested in replacing their tanks, there's the first question that I always ask and that people tend to ignore the answer to, which is really frustrating, is what torch are you using? Because the torch that you're using tells me a lot about what you might be going through. I can look at manufacturer specs on torches. So all the manufacturers have spec'd a specific pressure that you're supposed to regulate your oxygen to, and then they're going to tell you what their big, bushiest, fullest flame, how much oxygen you're going through at that pressure setting. Herbert Arnold's are spec'd to be about 29 psi. We've done testing in our studio and have found that Herbert Arnold, the 40, can go through between 10 liters a minute and 70 liters a minute. So 70 liters a minute is a lot, but for this kind of scientific work, you're probably using that 10 liter a minute, maybe 20 liter a minute flame more often. So you can always look up all the manufacturer specs. We have a link on our website if you're curious and trying to find all those links at once. I put them at the bottom of our Oxygen Solutions page to make it easier to find, if I'm using a CC, where can I find that information, So we link to all the manufacturers so you can find what you're supposedly going through. With scientific, we found the system that we have here, it's totally overkill for the room that it was running, because it's hard to say based on the torches that you're using if you're not quite sure what the usage is going to be. So the questions that I tend to ask, just to keep it kind of PC and legit and not degenerate, I guess, are you making hollow or sculptural, functional? Are you doing heavy prep? Are you making lots of milli, marbles? What kind of work are you doing? So I know if somebody says they're doing a lot of heavy prep or they're doing milli or large marbles, that they're gonna have a much larger volume. Maybe not consistently, because maybe they only do that a part of the time, and maybe they're doing a lot of hollow sculptural things the rest of the time. So anytime you're doing hollow sculptural, you're not going to be using as much oxygen, so it's not going to be that big bushy flame all the time. You're going to be switching back and forth. And a lot of those folks, if they have foot pedals, that helps them regulate as well, so you're not fiddling with the knobs and maybe, wasting oxygen, right? Exactly. So you can just hit that foot pedal or bump it, and switch back and forth between your flames. So does everybody understand that part, like the torch spec? Okay, so the next question I ask is, what do you set your oxygen pressure to on your regulator? Because that makes a huge difference. So if you're setting it at manufacturer specs, if your manufacturer specs 20 psi for the CC, you could be going through between 30 and 38 liters a minute, okay? But if you're bumping that up to 60 psi or 70 psi, which is way higher than they recommend, a quarter turn of a knob is going to be much more oxygen spilling out at that higher pressure. So you're going to be going through a lot more oxygen then. So if we talked to a guy that was using a Mirage, and we spec'd, 26 liters a minute. I mean, he might need, he was going through 70 liters a minute with a Mirage. So you can tell he was, his pressure was way up, and he was really blowing out the oxygen, So a 26 liter a minute system versus a 70 liter a minute system, we can totally handle it. It's much more expensive to blow through 70 liters a minute of oxygen, whether you're making it or buying it. And then the other thing is what a typical workday is. So, so if you're just hanging out in your basement 3 hours a night playing with oxygen, then your usage is going to be much less than somebody that's doing this for 8 to 10 hours a day. So once I have all that information, I can kind of put together a tank size, the number of concentrators to feed that tank size, and it's all a matter of then adjusting for typical versus peak usage. So your typical usage is going to be what you're going back and forth all day, and then if you're doing a lot of heavy prep, that's going to be your peak usage. Maybe you have 2 people on torches and you need 60 liters a minute for 15 minutes. So I can spec for that. We've got a little calculator, and we can kind of spec for, if you need 15 minutes of 60 liters a minute, but typically you're only going through 20, we can spec for that, so you don't have to buy this large system. You can have a smaller system that has maybe extra storage for those burst rates of your higher peak usage. That makes sense.
Yeah, you can tell we're
Yeah.
kind of more used to working with the artistic community, but this is sort of our entry into the scientific glass world, and it's an enormous pleasure working with people who don't just let,
Yeah.
you know.
It was really nice. I talked to a guy that's
Use
been
the flame to
blowing
push
glass
it.
for 50 years. He's joining quartz tubing. He's got 3 hand torches in his shop. He has 2 of the concentrators and our smallest unit with the smallest compressor even. So it would be a tabletop unit that's about that big. It's a 20-gallon reserve tank with the compressor that runs between 30 and 100 PSI. And he's doing that all day with no problems, because he's not cranking it way up. He's just conservative with his oxygen. He's been doing it for long enough that he knows how to work.
Yeah, very easy to meet the needs of the scientific community because of usage.
So we also have, there are various things that you can do if you want to cut back your oxygen usage, but not invest in a full system. So you can kind of cut back, and we have a couple people that do this. We've got a guy in California that was going through 4 doers a week?
5 doers a week.
5
Yeah.
doers a week.
Yeah.
And
180s.
instead of investing in a whole system to take over his shop, he figured he'd invest in half a system, and then he patches in a liquid. So that's what we've got going on over here, just in case with these artistic demos if they get out of hand. So we've got the system, but we've got a Y set up to patch in with the K tank. And basically what happens is the regulator on the K tank is set slightly lower than the lowest pressure that we want on the system. So if the system gets down to that pressure, then the K tank will kick in and take over until the system catches up, and then it'll kick in and then cut off the K tank again. So you can really cut back on your oxygen consumption that way too.
Yeah, that's a really important point. So, rather than build a really big system for the occasion when you get some people coming over to do a collaboration, which is more common in the artistic world, you build a system that works for you, and then you just patch in and you supplement, and you'll find that 1 K tank may last you a month, because it's only really going to kick in when you're exceeding the capability of the bigger system.
Yeah. If you're looking to cut back on your oxygen costs and getting the bare minimum system, it's going to put a lot of work on the compressor. So it may not, the system might need a little bit more maintenance because it's running non-stop pretty much, So you just have to keep that in mind too.
Yeah, and maintenance for these systems is usually just a piston cup change, which takes I'd say about 20 minutes. You will occasionally go through a piston cup.
It's 20 minutes.
Yeah, yeah. So any other questions? We were gonna.
I have one.
Go ahead.
So, you mentioned it earlier. How are you addressing humidity? Environments that are very humid.
Yes.
For instance, in the Midwest, some of us may have our studio in the basement, which
Yeah.
tends to be a little bit more humid. Do you recommend us getting a dehumidifier and using that in conjunction with our system?
It's not necessary. What I've found, and we're in the Midwest, where we build these in Lincoln, Nebraska, and I think our humidity exceeds Florida a lot of the time.
Mhm.
And it's pretty humid. But as I say, if you keep the systems running, so and I don't mean keep them running continuously. If you use the system consistently, then it keeps the sieve bed dry, and it expels the moisture. We've even got them running in. We've got one system running in Kauai, the farthest island out in Hawaii, and right on the ocean. And but he, you know, the guy who uses that system had a bunch of old machines in his basement, and so he pulled them out and found out exactly what happens when you try to store systems in a place like that. You know, that they basically, the sieve beds just blow because that zeolite just becomes a cake.
And that's the concentrator.
The concentrator, yeah.
Part of the system, yeah.
Yeah, maintenance on these, and you know, many of our systems have been running. You know, we've got systems running, you know, 5 years plus with no maintenance on the main unit. So it's really not that typical even to have to, you know, on the Mighty Mite, which does 150 psi, we have you might need to change a piston cup occasionally, but even that we've kind of instituted a better piston cup from working with the company that we get the compressors from, and that might be a thing of the past too. So, any other questions?
So we brought a couple of flow meters in just to kind of illustrate how much oxygen everybody's going through. So during the demos, if you feel like checking it out, this one right here is hooked up, and it did not register at all in the seminars. Like, it didn't look like we were using any oxygen, because this one is an SCFH. Does everybody know what that is?
Yeah.
What's the S stand for? Standard? Okay.
Standard.
Per hour.
Per hour, yeah.
So this is standard cubic feet per hour. So you'll find SCFH, you'll find SCFM, and then you'll find liters per minute. So the SCFH and the LPM are a little bit closer, and then the SCFM are for like bigger volume systems. So it's how much oxygen are you going through? It's a rate, basically, right? You've got your volume per time or
29 liters per cubic foot.
Okay, so with that you can calculate the 600. If you divide that by 60, then that's going to tell you CFM, right? We went from hours to minutes. And then if you divide that by 29, that's going to tell you liters per minute. So I'm more comfortable looking at liters per minute because the numbers don't have as many dots in them. Just makes it easier for me when I'm looking at torch specs, right? So 600 is roughly, I think I figured 200 liters per minute. You can figure it out if your calculators, if you got it. The 10 is roughly 50 liters a minute. So this is going to be for more torches, right? So with as little usage as we had with the hand torches, you know, those guys go through maybe 7 to 10 liters a minute. So they weren't really registering on this because it's, you know, the lowest mark here is about 50 liters a minute. You could kind of see with the little, you know, the smaller ones. And then anyway, we've got these other flow meters here that we've got, and these are, these run up to 50 PSI. They're gonna start limiting your oxygen if you set anything higher than that. The reading will be a little bit off for you. But these read up to 80 liters a minute. So these are really good for speccing single torches or a couple of small torches. So we've got this one hooked up to this torch here. So if it's not a problem, we'll just leave it hooked up and people can look at it while it's being used. But
why don't we demonstrate it right now?
yeah,
Sure,
let's do
sounds
that.
good.
Typically, when most glass blowers are you're doing, you know, building condensers and so forth, you're using a flame like that, or a lot of guys like, sometimes like that.
There you go. So that first flame was about 10 liters a minute, and this one's about 18.
Okay. So if you go to an annealing flame, which I think it's not going to use much oxygen.
It's like 12 liters a minute.
That's more of a, you know, typical flame right there.
Yeah, that's about 18 to 20 liters a minute.
Yeah, so really, a small system and 2 of these units will handle a CC very well.
And your heat, I've explained this to people, your heat is really coming out of your gas. I've noticed, and you have too, that, and we don't know why this is, because I'm not an artistic glass blower, but they just crank up the oxygen so high, it seems they're cooling their flame.
Cooling the flame, yeah.
Yeah.
The color chemistry though.
I'm
Yeah,
not
and
sure
that's,
why
I think
that is.
that was the Mirage guy. I think that was his issue. But then I've also heard more experienced glass blowers that will either hook up compressed air or work further out in their flame. If you want a cooler flame and you want to maintain your chemistry, don't here, work out here.
Yeah, but yeah, I think there are some situations with CAD colors.
Color
right?
chemistry is just something, I mean, until I started doing art, I didn't think about it in scientific, but it does apply. I mean, just using that annealing flame, you know it's highly, reducing everywhere except for outside that cone. And when you want to melt in that material or you want to burn off whatever material came out of your cut that you weren't able to clean out on a wet saw cut, for example, knowing your flame chemistry plays a big part in making sure that's an oxidizing environment for whatever's in there to come out.
Yeah,
Yeah.
absolutely, yeah. I think that's pretty legitimate. And we tend to, that's why we really need to know, when we spec a system, we really want to know what you're working. Because, if you are working a lot of CAD colors and you really need
Or
to have
striking
that
colors,
chemistry
then you
right,
really
we'll
do wanna know
overspec.
where you're going.
Yeah.
The silver, if you want to reduce it at some point,
Yeah.
it matters.
Yeah. And then we've got some guys that make really huge millies, and
Just
they're
get the heat where
melting
you can get it.
anything that's on their bench, and so you have to be able to make it through those stages. So, but
Yeah.
pretty much it. If you have any other questions, come up to us and we'll chat. And I really appreciate you.
Did you have the big outside flame on?
Yeah.
Was it drawing there?
Yeah. About as big as you're gonna use, I think.
That's almost 38 liters a minute.
Yeah. So unless you worked at that rate all day long, you really wouldn't need more than a small system with, let's say, 2 of these concentrated producing 20. Because you've got 20, but you've got maybe 1,000, 1,500 liters in the tank. So you've got the buffer. If you want to, the system basically kicks on at 100 psi. And then if you're exceeding that rate, if you're going through 30 liters a minute, the machines are pumping in 20, and you're going through 30, so you've got a deficit of 10 divided by what you have in the tank.
That right there is 50 liters a minute.
That's as much as I'll
But you'd never run that all day either, right?
do. No, I don't think so.
So you said that, given the demands that we're putting on this torch right now in this particular demonstration atmosphere, what would sort of the price point be on the machine you said would keep you going all day at that sort of usage?
So, okay, to run that torch at max all day.
Right. Not
well-
even max, but back and forth sort of like where we've been
back and
going.
forth all
yeah,
day.
I mean, I can't
Yeah.
think of it as a circumstance where
We're
I'm
talking
running my own.
7,500
Okay.
probably, right?
With everything, yeah.
With everything, and that's plug and play.
And then lifetime sort of with daily usage before you start getting into refurbishing and maintenance. as well.
Maintenance is going to really depend.
Okay.
It depends on how hard you run the system,
Okay.
but really it's not huge. The system comes with a 3-year warranty, so if anything happens within that warranty, we cover everything. After that, if you're out of warranty, it might just be that you need a piston cup. You might need a compressor rebuild if you're really running the system,
Yeah,
and
maybe
in
5
that
years.
case, we can swap out a compressor for you, and then you don't have to pay the whole investment. You just invest in the compressor.
We designed this system to be self-maintainable.
Okay.
So all the parts are plug and play. You open up the lid, you can unplug the compressor, take it off the plate, ship it back to us. So you can do all the maintenance. Same
Right.
with the digital board. So we designed it, and then if you don't want to mess with it at all, the whole head comes off for $45 at FedEx's to
Okay.
us. So we kept that in mind because we want this thing to run forever. This is an asset that if you're a glass blower, it's always going to be there, and not a whole lot to keep it going. And it's saving people a ton of money. And whether it's our system or any oxygen system, when you run the numbers, it's kind of a no-brainer. So,
You're not holding around K-tanks.
and you're not holding around. I mean, we could talk about safety. We had some interesting conversations earlier today about safety. And one thing, everybody probably knows this, but you never want to stand in front of one of these regulators when you open it up. We talk to a lot of people. We tend to get phone calls from people who've had some serious accidents because they're swapping. They're done with high pressure and they're done with liquid. And there's a lot of reason if you don't need to deal with a 2,500 psi tank in the presence of students or people. There's a lot of reasons to not do it now. It's not necessary.
We can get hurt easy just moving them around.
Yeah.
Moving them around, yeah. So,
What pressure do the storage tanks operate at?
the max pressure is 150, and then when it drops down to 100, everything kicks on and feeds in at that pressure. So it'll maintain that pressure while you work. If you're really getting ahead of it, it'll drop down. But you really, you have to be getting ahead of it for a long, long time before you're going to hit
But you
those
can
lower
keep
numbers.
using it as
Yeah, you
it's
keep
filling.
using it. And then it goes back up to 150 when you stop. It takes about 10 minutes or so for it to go from 100 to 150 and shut off. So it's really pretty quickly. Like if you take a break, take a coffee break, typically the machine's going to refill and shut off. So if you happen to be getting ahead of it during the day, I was in Italy with a bunch of guys who use a machine like this in Murano, and they had enough storage so they knew if they work hard until lunchtime, they could take a long Italian lunch and then come back, and it was all recharged and they could work into the evening. So that's the way they did it. They weren't trying to meet the needs all the time. They knew they could compensate the storage. Anybody else?
Yeah, if you have any other questions and you think of them later, feel free to come up. We talk oxygen all the time.
Thanks for your attention.
Thank you.